Hello, and welcome to a new virtual tour of the European Southern Observatory, or simply ESO, its acronym. My name is Farid Char, and with the producer Hector Salas, we are going to be your guides during this trip to ESO Paranal Observatory. So just a little bit about me. I have more than 15 years of experience in astronomy outreach and education. I am one of the guides of the Paranal Observatory since 2010, and I am also a member of an astronomy center for the University of Antofagasta. And regarding my personal hobbies, I am interested in telescope observations and astrophotography. Uh, so, as I told you already, I am not alone. I am with the producer, Hector Salas. So, how are you, Hector?
Hi, Fred. I'm happy to be here once again. So I'll introduce myself. I'm Hector Salas. I'm a PhD student at the Leibniz Institute for Astrophysics in Germany. I work mostly with topics related to the circumgalactic medium, that is the environment that immediately surrounds the galaxy. And I have been a member of the team of guides for Paranal Observatory since 2019. I started while I was doing my master's in University of Antofagasta. And as you mentioned, today I will be the producer, and that means that I will be changing the pictures and the videos, but also I will be reading your comments of the audience. And at some point, we will try to answer any questions that you might have. So please feel free to put any comments, any greetings that you might want to send, and we will read them at some point during the tour.
Okay, thank you, Hector. Yes, ESO wants to be with you during these virtual visits and bring astronomy directly to your home or wherever you are. So please remember you can send all your questions or comments during all this streaming, and Hector will be collecting the questions and we are going to answer them later. Okay, and please share this experience in case you like it with the share buttons on Facebook or YouTube. Okay, so we are going to start now with this virtual experience, and we want to help you to understand the place of our visit. So we are going to begin with some information about the European Southern Observatory, or ESO. So ESO is composed of 16 member states. We are going to look at a picture in a few moments, and I want to tell you that the headquarters of ESO are located in Germany. So also Australia has also joined ESO, in this case as a strategic partner. Chile is the host state and it's the home of all ESO observatories. So from the 60s and with those objectives in mind, ESO has chosen one of the best places on the planet for astronomical observations, the Atacama Desert in Chile. So during this period, Chile started several site explorations in order to attract international observatories such as ESO to our country. As a result, Chile offered its territory and ESO did choose the more suitable areas. So the mission of ESO is to design, build, and operate astronomical observatories. And why? To enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy field. So right now, you will see a picture with the three observation sites of ESO in Chile. So here we have the Chajnantor Plateau, for example. This is the site of the ALMA and APEX radio telescopes. ESO is part of these places for radio astronomy alongside other international partners. Additionally, south of the Atacama Desert, at 2,400 meters above sea level, we have La Silla Observatory in the Coquimbo region in Chile. So this ESO observatory is the home of several telescopes, such as the NTT or the 3.6 meter ESO telescope. And this one is using the HARPS instrument. In this case, this is an exoplanet hunter. And finally, we have the place of our visit, the Paranal Observatory. This ESO observatory is the home of the Very Large Telescope, or VLT, the most advanced visible light telescope on Earth. In the next few years, we will also have the Extremely Large Telescope, or ELT. This will be the biggest visible light telescope on Earth. And also near there, the CTA will be an array of telescopes. In this case, they will be focused on capturing gamma rays. Okay, so now we have a better picture. So right now, let's travel to the Paranal Observatory. So in this case, we have we are virtually flying to the Atacama Desert in the north of Chile, about 1,600 kilometers north of the capital Santiago, and specifically about 130 kilometers south of Antofagasta, the regional capital, and about 90 kilometers north of Taltal, the closest city. So now we are going toward the mountain top of Cerro Paranal, located at 2,600 meters above sea level. This mountain belongs to the coastal range, and despite its altitude, it's located at just 12 kilometers from the coast. And where's the ocean? Well, the Pacific Ocean is located below of this cloud cover over there. But why those clouds? If right here the sky is so clear, dry, and lonely? Well, this is because of the influence of the Humboldt stream. This is a cold stream near the coast of Chile and Peru, cooling the atmosphere and causing a phenomenon called the thermal inversion at about 1,000 meters above sea level, keeping below the cold, humid, and basically bad air for astronomy. But about the layer, instead, we have the hot, dry, and less dense air. So this is like the good air for astronomy. So the clouds are blocked by the coastal range, and near Paranal, the mountains are high enough, surpassing 2,000 meters above sea level. But what other natural barriers we have around this area? Well, about 200 kilometers to the east, we have the Andes Mountains. They are very high, with more than 6,000 meters above sea level. So this is another natural barrier blocking the clouds from Argentina and Bolivia. So the main result is this landscape, a place with an average of more than 300 clear nights per year, with a very clear and transparent atmosphere, making it ideal for observing the night sky. And also, here we are very far away from artificial light sources because of human activity. I mean, light pollution. So, this is one of the best places on Earth for astronomical observations. Okay, so right now we are going to change the view to have an even closer look to Paranal. So as you can see here, this is not an ordinary mountain. And now we can see the different telescopes and structures in the mountain. We are at the summit of Cerro Paranal. So do you know what Paranal means? Well, in the Quechua language, Paranal means whirlwind, possibly because of some whirlwinds forming in the desert. However, as I told you already, the atmosphere here is extremely quiet. So this observatory is like a true oasis. You will see how in one of the driest deserts we have a lot of life, and of course we have a lot of science. Okay, so right now we are going to visit the summit of Paranal. Okay, so now we are in the mountaintop. In front of us we have the Very Large Telescope, or VLT, its acronym. So if you see the amount of buildings here, 4 giant domes and other 4 small and rounded ones, I mean like this one, it is clear that the Very Large Telescope, um, in fact, is not only one, but a very special array of telescopes. So all this facility is the most advanced optical observatory on Earth. So let's take a closer look. here you can find the 4-unit telescopes or UTs, each one with a primary mirror of 8.2 meters of diameter. Okay, so the giant ones in your screens. And the other small ones are the auxiliary telescopes or ATs, each one with a primary mirror of 1.8 meters of diameter. So each UT has a name in the Mapudungun language. This is the language of the Mapuche people from central south of Chile. So here we have Antu, which means sun. This one is Cuyen, which means moon. This one is Melipal, which means 4 stars, but this is a reference to the Southern Cross constellation. And this one is Jepun. This word is a reference to the planet Venus. And the closer ones are the auxiliary telescopes. They are mobile and they can be moved using a rail system up to 30 different positions. So you can see the rounded ones here, here, and here are the auxiliary telescopes. And the rail system is this one. So you can see some stations there. So we have up to 30 different positions. They were specifically designed to work all together as a single big telescope with a variable diameter, able to reach up to 200 meters, as you will see in a few moments in a short video. Okay, so here we have the video. So the technique to obtain light from several telescopes is called interferometry. So we are able to observe much more specific details if you compare this with the individual telescopes. So thanks to interferometry, we can simulate a giant mirror to distinguish details up to 16 times fainter than a single telescope. So why don't we make small telescopes and we combine them to create a huge telescope? Well, interferometry also has limits, and some information is lost during its travel. However, it is still an excellent solution to observe objects too difficult to observe with our current technology. Okay, so right now we will come back to the tour screen. Okay, so now you will have the opportunity to visit one of the telescopes. In this case, we are going to visit the UT3 or Melipal, this one. We can't enter all the telescopes, but don't worry about that because the 4 ones are identical in size and shape. So the only difference are the instruments inside. You can learn more about the instruments on the ESO website if you want to know more. Okay, so now we are going to enter to UT3. And here we are. Now we are on the UT3 Melipal. So what can you see? Well, this is a giant telescope. In this case, we are on the last floor of this telescope at the same height of the main mirror in front, this one. So this mirror has 22 tons with 8.2 meters of diameter and only 17 centimeters thick, created from a ceramic and flexible material called cerudur. And the material of the surface is aluminum. It's a very thin layer of aluminum, only 80 nanometers. So this is the reflective coating to reflect the light from the stars. So how can we point this telescope to the sky without breaking it? Because this is a huge mirror and we have to preserve this mirror in optimal conditions. So we are going to explore this telescope from another angle. We are going to this level. So here we are in the platform level. And you can see from this perspective that the mirror is mounted over this white structure. You see? So this is a cell supporting all systems assisting the mirror, including something called active optics. And here you can see some little gray boxes. You see this one, this one, this one. This kind of boxes here, they are called actuators. They are a kind of piston, and we have 150 in total, controlled by a computer. So they are acting on the mirror during the observations in order to keep the optimal shape of the concave mirror, because the mirror has a concave shape. So otherwise, it could suffer deformations just because of gravity, physics. So those deformations, imperceptible in a first view, could be critical in the result of the observations. So how this telescope is working at night, how we can get the light and send the light to the instruments. We are going to come back to the previous screen to explain this. So here we are again in the telescope level, and we have a short animation to show you how the telescope is working at night. So the first step is to open the doors. Of course, in this view, this is exaggerated, but we have to open the dome, and in first place, the main mirror will receive the light, and because the mirror is concave, the light will be concentrated and reflected to the secondary mirror in the top. The secondary mirror is convex, and then will be reflected again to a tertiary mirror. And from there, the light will be reflected to one of the instruments. In this case, the instruments are like this kind of red, blue, and green boxes there. So basically, we have three instruments, three possibilities, and we can send the light to one instrument at a time. And in this case, the instrument will be in charge to convert the physical light into a digital signal. And the digital signal will be transferred to a control room. And in the control room, we have the astronomers working at night. At night, this place is completely in darkness, it's completely empty. We have no one here at night because we can do a remote control from another location. But during the day, we have some engineers working. So you can see some people there. They are engineers doing some kind of maintenance. So basically, they are preparing the telescope for the next observation night. So they are fixing problems, doing calibrations, etc. Um, so basically, during the day, the work is for engineers, and during the night, the work is for astronomers. Here you can see one of the instruments. As you can see, it's a big, big instrument. It's a big machine. At the other side, we have another instrument. It's not visible from here. And at the base level, we have another instrument. So we have three instruments in total. So this is what happens here. This is how the telescope is working. And as I told you before, the astronomers are not physically here. They are in another location. And this will be the next stop of this visit. So that's the explanation here inside of Melipal. So now we are going outside because now we are going to the next stop. The next stop is the control building, this one. As you can see, the control building is located in the mountaintop, but in a different level. It's not in the same level of the telescopes. So I can show you this building from the other side. So you can see the control building here. It's a big building, as you can see, and the astronomers are located in the control room. The control room is basically in the last floor, and they are working here all night. So this will be the next stop. But before going there, I think we have some time to answer some questions in case we have some questions from our visitors. So, Hector?
Okay, so we have several greetings. We have Snowy saying hello from Denmark. We have Sway Graven who sent us love from Amsterdam. Dani Solano says saludos. We have Cynthia from Australia saying good day. We have here someone from Canada. We have a couple of questions from Alicia. Um, she put it in Spanish. So, nos pregunta si será posible tener notificaciones cuando hay observaciones interesantes. So in English, she's asking us if it's possible to have some news about interesting results. And I guess the closest to this would be the ESO press releases that ESO puts every month, right? So we can put the
Uh,
link for.
yeah, excuse me?
I will put the link for the press releases in the chat later.
Yeah,
And
yeah, sure, sure. Because ESO is usually doing some press releases of important achievements. In some cases, discoveries. In some cases, some important publication. So basically, we have a lot of different information from ESO, and this is very interesting because ESO has a lot of publications because it's the most productive observatory on Earth. So, I mean, we have, well, ESO has Paranal, La Silla, and is participating in ALMA as well. So, there are a lot of different discoveries or achievements or new information coming. So yeah, we have a lot of information in English and Spanish. So yeah, it's very important. So thank you, Hector, for the link.
yeah, and Alicia, she also asked us about earthquakes because Chile is a very seismic country. So do we
Yeah,
have any
sure.
special
So
measurements for that?
yeah, well, in this observatory, in the same way like a building has some protections against earthquakes, the observatory has also some protections for in case of an earthquake. So essentially, we can be okay even with an earthquake of 8 magnitude with epicenter in Antofagasta. And we have some protections in the underground, basically. And we have had some earthquakes in the past. Um, but so far, no important problems, no damage to the mirrors. In any case, after an earthquake, if the earthquakes are in, I don't know, mid or high intensity, maybe some engineer will go to the telescope to check everything. Um, but so far, fortunately, we haven't had any important issues with the earthquakes.
All right, thank you for your answer, Farid. And I don't see more questions from our audience, so I will invite them to send any question or doubts or comments that they may have. And I will ask you a question myself. So we're doing the spiritual tour, but is it possible to go to the observatory in person and see the facilities?
Yes, of course. You can visit Paranal in person every Saturday. We have tours at 10 a.m. and 2 p.m. The tour is about visiting the facilities. I mean, very similar to this virtual experience, but of course in person. And the tour is about 1 hour and a half. You need to do an online booking at least maybe 2 weeks in advance because we have limited slots. And just for your reference, Antofagasta is about 1 hour and 30 minutes uh, away from Paranal. But of course, it's better to, maybe have maybe consider 2 hours of driving because you need to arrive in advance. So basically, you have to visit the observatory in your own car or transportation because we don't have I don't know public transportation going there. But you have the possibility, as I said, to visit Paranal at 10 a.m. or 2 p.m. every Saturday. You need to do an online booking on the ESO website in a specific section about public visits to the observatory, and the visits are in Spanish or English. So everyone is welcome to visit Paranal in person.
Yeah, so if you ever had the opportunity to travel to Chile, consider going to Paranal, and the tours are completely free.
Yeah,
Uh,
sure.
I guess we can continue, and then we have a second break for more questions at the end. So please, if you have any more questions,
Sure.
don't be afraid to send them.
Okay. So thank you, Hector. We are going to visit the control room now. So let me move, and we are going to visit the last floor of this building. Okay. So we are going to visit now the control room. And as you can see, this is the control room of Paranal. And we have several workstations. Okay, so we have workstations for each telescope. In this case, this workstation, for example, is for Melipal, for UT3. So in this workstation, you can see several computers. We have several computers here for different purposes, and we have people working here. Okay, so this workstation is specifically for the Melipal telescope. In front here, we have the workstation for the UT4. UT4 is Jepun. So the same thing, we have different computers for different purposes. We have some people working there. And as you can see, this place is like an office. It's like a big office. Um, and, of, and of course, during the night, we have the scientists in this location, and they are working all night. If we continue working uh, for this virtual corridor, I will show you the remaining workstations. Here we have the workstation for UT1 and 2. So the same thing, we have different computers for different purposes. And in the opposite workstation, this one, we can do the remote control of Kuyen UT2. Okay. So basically, all the telescopes, instruments, and systems explained before are controlled from here. So during the day, engineers, technicians, and scientists are working to prepare the telescopes for the next observation night. Each night, we have a telescope operator and an astronomer per telescope. Okay, so for example, I will show you this workstation in detail. And in this workstation, for example, you can see again the computers, and we have, for example, this person. This person is a telescope operator. Okay, and this person is usually working with an astronomer. So the astronomer, let's say, is this person. So the telescope operator is in charge of the technical details and the movement of the telescope. So it's like as the pilot of the machine. But the ESO astronomer is in charge of directing the scientific observations and will decide the next steps. So it's something like the co-pilot. So the observations are performed by experts from ESO for scientists from all the planet. Okay, so this is basically what happens here. Again, this is like a regular office with a lot of computers. Is with people all night, but we don't need a lot of people. Usually, only two persons per telescope, and that's it. Maybe sometimes the astronomer can be rotating in case we have a visitor astronomer, but usually you don't have a lot of people in this area. Okay, so this is the explanation of the control room. So now we are going to come back to the main platform. And well, now you have a lot of information about the observatory and the people working here. So now I want to invite you to know more about the main scientific milestones made from all ESO observatories. I mean, from La Silla, Paranal, and Chajnantor. So scientific staff from different countries are using the ESO telescopes to study objects near to our home, solar system, but also others located in the more distant places in our universe. So now we are going to explore a list of the top 10 discoveries from ESO sites so far.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when two independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay. Okay, so this was the top 10. I hope you enjoyed it. But we have something else. We have something like a bonus track. So let's take a look at this right now. This is basically some important news from some time now. A team of astronomers were able to capture the first image of a black hole. The Event Horizon Telescope, or EHT, its acronym, is an array of 8 ground-based telescopes distributed on the planet, working as an international collaboration. And they were able to achieve the first direct evidence of a supermassive black hole in the center of Messier 87, a massive galaxy in the close galaxy cluster in the Virgo constellation. This object is located at 55 million light years from Earth, and its mass is about 6,500 million times the mass of our Sun. Okay, we hope you liked the top 10. This was only a fraction of the discoveries, thanks to the ESO telescopes and the scientific stuff behind them. So now we can continue. And from the platform again, we are going to do a very special activity, thanks to this virtual tour. We are going to observe the night sky from Paranal. So in this picture, the sky is almost completely dark. We can see the last traces of light from the twilight, and the moon is below the horizon, and the sky is full of stars. So it's, of course, very, very beautiful. Okay, so here we can see a very popular constellation just above of the Antu telescope, the first one in the screen. So this constellation, I am going to do a close-up, is Orion. Okay, this one. So Orion in the mythology represents a hunter, and you can recognize this constellation because of the 3 stars here, somewhat aligned, representing Orion's belt. And inside of Orion, we have something else. We have a very interesting object. We have this object, and this is the Great Orion's Nebula. So the Great Orion's Nebula is basically a star-forming region, and it's a very bright object. It's actually visible to the naked eye, and of course you can observe this object with binoculars or even a small telescope, and looks very, very nice. Okay, so the Great Orion's Nebula is in this constellation. So we are going to change the position now and move to the brightest star of the night sky. That is called Sirius. Sirius belongs to the Canis Major constellation, and in the mythology, it represents one of Orion's hunting dogs. So basically, the constellation Canis Major is connected in the mythology to Orion. Okay, so basically, this one represents one of the hunting dogs of Orion, and in this case, it contains the brightest star in the sky. Now, a little bit down, next to An2, the telescope here, we have another important object. I will do a close-up again, and you can see something here. This is an open cluster. This is a star cluster called Pleiades. This cluster is located in the Taurus constellation, and you can see that it's very bright. With your naked eye, you should be able to observe at least the main 7 stars. Okay, so it's actually in the mythology is associated with the 7 sisters. So this is a very popular object of the night sky. Okay, so the majority of those objects are visually close to a specific area. They're very populated with stars. Actually, we are looking at one of the Milky Way arms. So basically, here you can see this kind of path of light. We have an important concentration of stars here because this is one of the Milky Way arms. And the Milky Way is our galaxy. And our sun is only one among hundreds of millions of stars there. So during the winter in the southern hemisphere, we can see the center of the Milky Way. And this is another area full of stars between Scorpius and Sagittarius constellations. And you can see all this area from this hemisphere, from the southern hemisphere. Okay, so now we are going to move to another location in the sky. We are going to move to another place to find 2 spots in the night sky. So we are going to move here, and the two spots are those ones. What is this? Well, those spots are the Magellanic Clouds. Up there, we have the Large Magellanic Cloud, and down there, we have the Small Magellanic Cloud. They are not actually clouds, of course. They are galaxies with an irregular shape. Both galaxies are visible to the naked eye in a clear night like this one. The name refers to the records from Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So during this time, the people have no idea about what a galaxy is. So that's why they believe that they were clouds. Now, another important area right here, I will show you, is this, because here we can find the smallest constellation of the sky, the Southern Cross. So the Southern Cross is this one. As you can see, the cross is like tilted a little bit. This is an easy constellation to find in the southern sky, only visible from this hemisphere, and a good guide to find the South Celestial Pole. So the South Celestial Pole is a projection of the Earth's South Pole. So during the night, the stars appear to revolve around this point. So in order to find the South Celestial Pole, because we don't have a bright star in that area, one of the techniques to find this point is to project, to extend the longer stick of the cross, of the Southern Cross. So this one. So we had to project this longer stick about 4.5 times in order to find the South Celestial Pole. So we are going to project this stick about 1, 2, 3, 4.5, and more or less like here, you can find the South Celestial Pole. And if you look at the horizon from this direction, basically you are looking at the south cardinal point. So this is a good way to find the cardinal points in case you are lost in the desert, for example. Okay, so this is the conclusion to our visit to the mountain top at night. So we are going to return to the main screen in daytime in order to visit the last stop of this virtual visit, of this virtual tour. So the last stop is not here. It's located in the base camp. So we have to rotate the view, and I have to show you the base camp of Paranal. Here you can see a panoramic view of the Atacama Desert, and there you can find the the base camp, the Paranal base camp. So this is the base camp, and in this location we have different facilities. For example, we have some rooms for contractors. We have some offices for informatics, for example. We have a warehouse. We have the mirror maintenance building. We have a gym. We have a lot of different facilities for the people working here. We have more than 150 people working here in total. So this is like a mini city, actually. But the place I want to show you is located over there, and is the residence. So this is the residence of Paranal, a place where the ESO staff can stay and rest. And the residence is the home of the ESO staff during the stay here, because the people is working on a shift system. So they can spend like 7 days here and 7 days at home, for example. So this is basically a place for all people with a contract with ESO. It could be engineers, astronomers, etc. And in order to access, we have to use this ramp. This place is not exactly underground. It looks like underground, but if you look this place from the opposite side, you will see a normal wall with windows. Okay, so but this place is basically taking advantage of the shape of the land. Okay, so that's why we need to access using this ramp. And this thing here is something like the roof of this residence. Okay, okay, so we are going to enter now. And here we are. So here the workers can enjoy a more humid air. They have a swimming pool, they have green areas, and of course, it's a very nice place. So they can enjoy with different facilities here. They have the restaurant over there. So all workers can go and eat there. Here we have like the lobby. We have the reception. So this is very similar to a regular hotel, but in this case, it's only for the ESO staff. And this residence has 108 rooms. So it's a very big facility. Okay, so with this view of the residence, I think we have some more minutes in order to answer the last questions. So, Hector?
Okay, so we have a few more greetings. We have from Susana, saying that this is wonderful. Also from Italy, Royal Vasquez Marina says hello. And you have a question from Irmeli Elandriel, I hope I pronounced that right. He says, well, hello from Sweden. And he asks us, is there a part of the sky that we're specifically observing or especially observing?
Well, no, not exactly. Actually, we can observe any part of the sky, but of course we have a limitation. We can observe only places in the sky that are visible from this hemisphere and from the specific coordinates of Paranal. So basically, uh, any place that is visible from the southern hemisphere um, is of course a possible target. One of the main interesting things about the southern hemisphere is that during the winter months in this hemisphere, like May, June, July, you can see all the Milky Way. You can see all the Milky Way in the sky. Of course, this is a difference if you compare with the northern hemisphere, because in the northern hemisphere you can see something like I don't know, like maybe 75% or something like that. But from the southern hemisphere, you can see the full galaxy. So this is very very interesting, and of course, there are many nice and interesting objects possible to be observed from Paranal.
Yeah, and just to complement a bit your answer, it's really going to vary year from year because astronomers from all over the world they send proposals to get observation time at Paranal, and depending on which proposal gets accepted each semester, to what we're going to be observing is going to be changing. And some people are interested
Yeah,
in
yeah,
studying
exactly.
planets, or other people start to study galaxies. Uh, there are some places that are studied more than others. For example, the place where the Hubble Deep Field image was taken has also been observed from Paranal and with many other telescopes. And since there is a lot of data from that part of the sky, you can complement the different data set. So you start to see that it gets observed again with James Webb. Then it gets observed again with some X-ray telescopes or things like that. So you can complement the data that way. Okay, we have a question from Jose. How high is the telescope at sea level in feet? He's from Puerto Rico. Uh,
It's like um, um, well, we don't use that unit in the South America, but uh, uh, I don't know. I have to calculate.
okay, so 2,600 meters, that's the height of Paranal Mountain, is,
Uh-huh.
according to a quick search, 8,530 feet.
Yes, yeah, that's right.
So that's the height of the main platform at which the observatory is.
Yeah, that's right. Um, yeah, so basically, it's any observatory has to be very high, okay, because we need to be far away from the clouds. We have to be above of the thermal inversion layer, and we have to be far away from light pollution. So this is like the normal, usual altitude for an observatory. Um, so yeah, most of the astronomical observatories are about same altitude, like 2,000, 2,500 meters above sea level, something like that.
All right, and I think that's the last question that we have. So I will say my goodbyes, and it was my pleasure to be here with you today. And please, if you know anybody that you know that might like this kind of content, let them know that we're doing these spiritual tours every Saturday, switching between Paranal Observatory and the Sea Observatory, between doing this in English or in Spanish. So please keep an eye on our social networks to know when the next tour is going to be in English language. With that, I say goodbye.
So we remind you that all this visit information and pictures is available on the ESO website. And so in this way, we are going to finish now this virtual tour. And I hope you like this virtual experience. So please stay alert, as Hector said, to the ESO social networks to know when will be the next virtual tour, Spanish or English, Paranal or La Silla. So on behalf of ESO, I want to say thank you very much for your presence. So thank you and goodbye.